Hello everyone. Now in this video you are going to learn how to draw the projections of a line when it is inclined to horizontal plane and vertical plane. That is, the line is inclined to both the planes. In the previous two tutorials you saw the same. The line is inclined to both the planes when an end of the line is fixed and the other end is moving. But in this question you can see on the screen that a line is inclined to HP and VP, but the midpoint is above HP and in front of VP. It says that now in this case the midpoint is stationary, not the end line. So now let us see how to draw this one. So this time I made it very simple compared to this one previous tutorial, so that you can follow the same procedure for any case of line inclined to both the planes. So you can see that this question procedure, not the question, you can see this procedure. First, after seeing the question, you can split the question into two parts, that is horizontal inclination and vertical inclination, and draw its projections. So projections of a line when it is inclined to horizontal, projections of a line when it is inclined to vertical. After that, note down the true length of views, shortened length of views. After that, the fourth, fifth I will explain in detail in the coming. Okay, so first let us have a look how it looks like. You can see that according to the question, the true length of the line is 100 mm long, which is inclined at 30 degrees to the HP and 45 degrees to the VP, and its midpoint is 35 mm above HP and 50 mm in front of VP. You can see that this is the first quadrant, the reference plane or reference line XY, vertical plane and horizontal plane. So first I am splitting the question into horizontal inclination. You can see this red color line, the line PQ is 100 mm long, which is inclined at 30 degrees to horizontal plane. You just concentrate only on the red color line. The red color line is inclined to horizontal at an angle of 30 degrees. When the observer views from this side, you can see the midpoint is also 35 mm above HP and 50 mm in front of VP. So this is the true line. When the observer sees from this side, you can see the projection, that is the front view falls on the vertical plane P dash Q dash, and when you see from the top view falls on the horizontal plane, that is P Q. So you can see the same here. The front view is 35 mm above HP, the midpoint which I noted as M dash. The front view is inclined line P dash Q dash. You can see P dash Q dash. Okay, now that is P dash and Q dash of 100 mm length. Next, top view. If you draw the projectors till the in front of VP distance, that is 50 mm, you will get the top view PQ. You can see this is in front of distance of line PQ. Now the same I am going to draw. Okay, so first I will mark the distance 35 mm above HP and 50 mm in front of VP. Take the line, switch on the ortho, 35 mm above HP, 50 mm in front of VP. Okay, see, now the line I marked, the midpoint I marked it as 35 mm above HP and 50 mm in front of VP. Draw a line, okay, 100 mm long, inclined at 30 degrees to HP. Yes, this is the one. Now I am moving midpoint, I am just placing it here. So I want to draw the projections. The top view falls here. be exactly at in front of VP, as I explained in the yes. This is the front view. Again, I'll draw a line here. Line weight display on. Okay. Now you know that P dash and Q dash, and its top view is P Q. See, the same P dash, Q dash, and its top view is PQ. Now the horizontal plane inclination projections finished. Half of the part finished. Now I am going to take the second part. Now you can see this blue color line. This is also a line PQ. Just for the sake of understanding, I taken the new color for the second case, that is vertical plane inclination. Now this line, the same PQ line, is inclined at 45 degrees to vertical plane. Inclined at 45 degrees to vertical plane. When the observer views from this side, in the front view, you will see a horizontal straight line which is of compressed one, shortened one. So P1 dash, Q1 dash. But when you see from the top, you can see the true length of a inclined line. The same you can saw in the projections. See, vertical plane inclination 45 degrees. The true length line is 100 mm. And when you draw the projector still above HP, you can see P1 dash, Q1 dash. Here I am taking the new notations P1 and Q1 because I am taking the second case now. So that's why instead of P and Q, I am taking it as P1 and Q1. The notations will follow according to that. So now I am drawing the second one. Take the line 100, tab. Now 45 degrees, minus 45 degrees. Okay. Again I am moving this line. Okay. Just I am placing it here. (30 degrees to HP). (45 degrees to VP). So now as I says that, I forget to mention here, sorry. This is M dash. This one is a new case. Instead of M, I am taking it as M1, midpoint 1. Okay. And this one P1. And this one Q1. This is the top view. Top view of a line when it is inclined to vertical plane. Okay. Now I am going to draw the projections till the above HP. This one. Okay. Project the line till here. Okay, just I am taking the yellow color line. Okay, so this is P1 Q1. The corresponding front view notations are P1 dash, Q1 dash. Okay. See, perfectly. It is 100 mm. 100 mm. According to the question, the midpoint is here exactly. 100 mm line is inclined at 30 degrees to HP. 100 mm line is inclined at 45 degrees to VP. Perfectly you made this one. First one finished, second one also finished, because still you have drawn the projections of front views and top views. Now it's time to mark the true and shortened views. So I will do one thing. I will take the M text. Simply I can write true front view TFV dash and then shortened top view, enter, true top view and then shortened front view. You will see what it is. Okay. Note the true and shortened views. You can see here. Okay. See, when the line is inclined to HP, in the front view you can see the true length of the line as a front view. The true length, there will be no compression in this length. Exactly you can see the 100 mm length. There will be no compression in the length. So that's why I taken it as true front view. That is true length of front view. So that's why I am noting it as P dash Q dash. True front view as P dash, sorry, it should be small letters, P dash Q dash. Okay. True front view as P dash Q dash. But when you see this line, the red color line, from the top you can see the compressed line, compressed or shortened line. What this view is? Shortened view, top view. It's a top view. So that's why I took it as shortened top view. Shortened top view. What is this line? P and Q. So shortened top view is PQ. Okay. Horizontal inclination case finished. Now if you see the vertical plane inclination, that is 45 degrees. When you see from this side, you can see that this inclined line will observe as a horizontal straight line which gets shortened or compressed one. So the notations is P1 dash and Q1 dash. What is this view? It's a front view on vertical plane. So shortened front view is P1 dash Q1 dash. Shortened front view is P1 dash Q1 dash. Okay. Now if you see this vertical inclination line, when you see from the top, you can see the true length 100 mm as a inclined line, that is true top view. The notations are P1 Q1. If you write this one, it will make you easy to construct anything. Okay. Now you finish the third part also. Third one also. Again, here I am saying that rotate the shortened front view to true front view locus. Rotate the shortened top view to true top view locus. Why? The question is why? You can see here. See, first according to the front view. Here you can see this shortened front view belongs to the pi inclination or vertical plane inclination. Shortened front view is P1 dash Q1 dash is P1 dash belongs to the vertical plane inclination. I am saying that to rotate to the true front view locus. You can see here, when you rotate this shortened front view to true front view locus, it indicates that you are rotating the projection of pi front view to theta front view locus. Pi front view to theta front view locus. That indicates that you are going to take its final position, that is when a line is inclined to theta and pi. line is inclined to theta and pi. So that's why this shortened front view, I am tilting it to the locus of the true front view locus. So with which as center? With this as center, I am rotating till the true front view locus. You can see this is the true front view, P dash and Q dash. That's why I drawn the line here, locus of Q dash and locus of P dash. You can draw the same. Take the line, a horizontal line, okay, again draw a line here, perfect. Yes, so here this is of locus of Q dash, this is locus of P dash. As I says that this is the shortened front view. You can see shortened front view is P1 dash Q1 dash. Now you have to rotate this line with this as center to meet this true front view locus. How? Take the arc A, center, this is the center point of an arc, starting point as this is the radius M dash Q1 dash, and you have to rotate till here. Yes, see, till you rotated here. Okay, now you have to rotate this one also, P1 dash to P dash locus. Again take the arc A, specify center, and this is the center and this as the radius. Now you have to rotate like this. Perfect. See, it matches here. So just keep it as text. This one you write it as Q2 dash, this one you write it as P2 dash, the new points. Okay, so P2 dash and Q2 dash, you have rotated the shortened front view to true front view locus. So we got the final front view points. The next point is rotate the shortened top view to true top view locus. You can see here in the top view, if you see, this PQ is the shortened top view. The true top view is P1 and Q1, means you are having the P1 Q1 true top view with respect to the vertical plane inclination, whereas this PQ is the theta case. So that's why you are rotating the theta top view to pi top view locus. When you rotate this one, you can see that the final top view will be in the form of both the inclinations. So now I am rotating the same with M1 as center. I am rotating shortened top view to true top view locus. Okay, again taking the arc, shortened top view is PQ. So this as center. Okay, I forget to draw the locus. You draw the locus here. First a horizontal line, locus of P1 also. Okay, now take the arc, center point as M1. Okay, center point as M1, and now the Q should rotate here. So to make the opposite direction, press Ctrl. Okay, perfect. It cuts here. Now again the arc A, center. Now this as the center and this as the radius. Press Ctrl. Yes, perfect. See, now this one cuts here and this one cuts here. Text, note down the point as P. This point as, because it belongs to top view, right, P2, and this one as Q2. Okay, perfect. Now these are the new points which we got for the top view. So finally we finished these two, fourth and fifth points also. Now it's time to draw the line to show the final projections. See, take the line, and this is the intersected point from here to here. Perfect. And from P2 to Q2. So for the final projections, I am giving another color. This is the main which are asked in the question to draw the projections. So that's why I am taking the green color line and I am giving 0.35. Okay, let me take the dark color only, because the green color won't be visible on the paper very well. Okay, I am taking the blue line. So P2 dash Q2 dash is the final projection, front view projection. P2 Q2 is the final top view projection. So to evaluate whether this is correct or not, so when you draw a line from Q2 to Q2 dash, it will be a straight line. Switch on the ortho, you can see that you got exactly 90 degrees line. That says your procedure is perfect. Q2 dash and Q2. Already M dash and M1 is correct. Because it is on the same line. Again, take the line from P2 dash to P2. See, here also exactly perpendicular. Hence the answer is exactly correct. So now final projections also we finished it. The next step is measure the alpha, beta and projections. So DAL, dimension aligned. The length of the distance from the P2 dash to Q2 dash is 70.71. Okay, now this one P2 Q2 86.6. okay, so this is the projection. Now we made the length of the line projections. Now angle alpha, dimension angular with respect to horizontal plane, that is 45 degrees. Alpha is 45 degrees here, beta is 55 degrees. So with this we completed the procedure. So I want to show you that after drawing the projections, see, this is the P2 dash Q2 dash and P2 Q2. So with this we should not stop. Actually, as per the drawing we can stop here, but to realize why we have drawn, you can see that if you draw the projectors Q2 dash to Q2, already you made it here, but in the 3D I am showing, see, this is orthography. When you draw a line and P2 dash to P2 and when you draw ortho lines, so this is the final position of the line, which is in the real time it looks like this. When a line is inclined to theta to horizontal plane and pi to vertical plane. So as per the question, this line is inclined at 30 degrees to horizontal plane and 45 degrees to vertical plane. So in the real time the line looks like this. So with this we finished the complete projections of the line when it is inclined to both the planes. So to keep this procedure, this one is not required in the drawing sheet. This is just for your understanding purpose. Okay, so take the line, it should be neat. Trim, TR, double enter. Yes, because presentation is very much important. Okay, now text, locus of q dash, this line belongs to locus of q dash, locus of p dash, locus of p1, locus of q1. So q dash is correct, just edit it. Perfect. P1, Q1. Control S. So go to the layout. Okay, click on the paper, zoom, window. So this is what you need to present at the time of submission. That's it, guys.